Here we go. We have a question. Count the number of possible triangles. So you have given an integer array and we need to find the number of triangles that can be formed with three different array elements as a length of the three sides. So a note here is a triangle with three given sides is only possible if sum of any two sides is always greater than the third side. It means a plus b must be greater than c. So we have given this example, and in this 3 and 4 summation 7 which is greater than 6, and these two values means the minimum two values is 10, so it is greater than 7. In this we got 9 is also greater than 7, and here we got 7, but 7 is equal to 7, not greater than 7, so this is not possible. The answer is 3. And this is a bigger test case, you can verify it. The answer is 6 and explanation is also given, and in this case we have not find any answer, so this answer is 0. So now let's build the approach. So for this, the array can be unsorted. So first thing is to sort the array. So then and only then we can solve it in order of n square. So first, the brute force can be order of n cube, but I will not gonna teach that. First of all, sort the array, so it will take n log n. Then initialize your L and R pointer to the first and last value. Then check the summation. Is the summation actually we want a plus b, it must be greater than c. So let's start with this value. We don't have any target. I don't know why I have taken target. Anyways, so let's start with the bigger value. So we can take any values and find whether the summation of two values is greater than this value. Let's check. We have L and we have R. L is pointing to 0th and R is pointing to I minus 1th index. So what's the summation? It is 8, which is less than. So let's increment our answer. To increment the answer, we need to update our L. We got summation 9, still less. We got summation 10, still less. We got summation 11, still less. 12, 12, 12, and 13, still less, still less, and 14, 14 is still less, and we cannot assign L and R to the same index, so we have not find any value for 18. Let's start with one lesser index, so our I is here. Then we still have L and R. What's the summation? Summation is 8, means this is a valid pair. This is a valid pair, and all the values between the range is also a valid pair. How? Let's verify it. If this is a valid pair, means 1 and 7 is a valid pair. It means 2, which is bigger than 1. If I sum up with 7, it will surely give me a summation which is greater than 7. So this value give me greater value, this value, this summation will give me greater. This pair is also valid, this pair, this pair, this pair, and this pair. If I pair up with this index, so how many pairs do we get? So answer will be first this and seventh pair, this pair, this pair, this pair, this, and this one. That's it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. And now let's check the index. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the range, we need to find the range. So the answer is R minus 1. Just add the answer. So we got 9 for this value. Let's check for the next index. So should we update our L or should we update our R? So we have used the rth value. So rth value will now will not pair up with any pair, not pair up with any other pair, because we have already find the pairs that are valid. The pairs are R minus L. So it's time to update our R. We need to find our new R value. What's the summation? It is 7, which is equal to. So if the value is less than or equal to the target is this. it means we need to find more values, bigger values. So we need to update our L. So we got 8, which is greater than 7. What's the range? 8 minus 1, it is 7. So we have find 7 more pairs. 1, 2, 3, 4, 5, 6, 7. So we have used all the pairs and I paired up with the value R. It's time to find a new R value. So we got this value. Then is the summation valid? Yes. Find R minus L. Then update your R. What's the summation? 7. The value is less. Update L. What's the summation? It is 8. And the answer will be, the pairs will be R minus L. So this is a valid pair. Update R. This is also a valid pair. R minus L. Also a valid pair. R minus L. Also not valid pair. So need to update our L. So we got this index. So we have find all the values, and the third side is C. In this case, C is 7. It's time to find our new C. Our new C will be this. So same approach will go here. So our first loop start from the backwards. So it will be it will start from n minus 1 till 0, and you can like assign to 2, but anyways. So then we have L to 0th value and R to R minus 1th value. So we have two pointer, simply two pointer, and the condition is while L is smaller than R. So this condition, this for loop will take order of n, and this for loop will also take order of n. And before that we need to sort the array, so it will take n log n. So the total time complexity is n log n plus order of n square. So in the worst case it will go till n square. Let's code this. Code is very simple. So we need to sort the array and answer. Start from the backwards, L and R. While this condition holds, find the summation. Summation is greater. This is a valid pair. The pairs are in the range of R minus L. Then update your R. As values summation is less or equal, we need to find bigger values. So update your L. At the end, just return the answer. Let's submit this. I already talked about time and space complexity. Code is provided in the description box. And if you guys have any doubt, feel free to ask in the comment section. And thank you all for watching this video.